I've been having fun just adding an unexpected speaker to the lineup that's not officially on the lineup. This is Niels. Niels is a HalfStack legend. There's probably 4 or 5 people here today who, if they ever submit a talk and it's not a vendor pitch, it's an automatic yes, just because they've been such an awesome part of the history of HalfStack. Niels, Joe, Chris, Jonathan is not speaking today, but he would fit that list. Just people who've helped make the conference what it is just really awesome. So Niels is going to give a 10-minute talk that has something to do with QR codes. And that's all I know, and I was like, sure, QR codes, that's amazing. Like, why not? I don't think we've had a talk about that before. But sharing cat gifts after the twitpocalypse is an even more compelling title than what you told me, so that's cool. So, are you ready? Yep. All right, without further ado, here's Niels. Thanks.
So, hi. My name is Niels. And I'm HTML5 test on Twitter. At least I was this morning. Let me check. Yeah, I'm still HTML5 test on Twitter. Of course, it's impossible to predict when Twitter will explode or implode, or it could be this afternoon, could be tomorrow. Oh, wait. Yes, right, that's better. The blue verification badge. Now, of course, the badge doesn't mean anything. You can change your name to anything. So if you want to call me Elon, that's fine too. Just not tell him, okay? Because then he will probably personally suspend my account. You can call me Lord Cornelis too. I like this. This is... Twitter verified it, so you have to call me Lord from now on. Twitter says so. Now, I don't want to risk getting my account suspended, so did I buy a 5 square feet plot of land in Scotland so that I am now a landowner? And according to Scottish tradition, I now have the right to call myself Lord? Yes. Yes, I did. So my name is Lord Cornelis Leenheer. So now, on one hand, I would love to see Elon fail miserably, and last week was a lot of fun. But on the other hand, I've been active on this platform for almost 15 years, and I owe a lot to the community on Twitter. I have good friends that I met on Twitter for the first time, and how could I make dad jokes without Twitter? But tweets do have consequences. This happened to the Eli Lilly stock after this tweet. Now, they actually deserve this for artificially inflating insulin prices. But it's not completely innocent. So, just one troll needs to get on Putin's nerves, and he'll go thermonuclear on our asses, and bombs will rain down on the Twitter data centers. So a nuclear twitpocalypse is basically inevitable. So 44 million down the drain, and everybody will be dead. But let's not focus on that. So some of us will survive and will live on the ground for a while. We'll be conquered by talking apes and monkeys. But luckily, some astronauts will rescue us from slavery. I saw that in a documentary once. So now what? We need to rebuild society. We need to bring civilization back, and that means sharing meaningless photos of our food. And of course, cat gifts. And I say GIF because after the twitpocalypse, everyone agrees it's GIF. All the GIF people will be eaten by cats, or by monkeys. Now, the most important question, will there actually be any cats left? Or will they mutate into horrible monsters like flurkins that will come out at night and will try to eat our children? So those are the important questions I think about when I lay awake at night. But the good news, everything we need to rebuild society is already in our browser. So if you were sensible like me, you would have bought a massive supply of mutant cat repellent, of course, but you also installed a GIF sharing PWA beforehand. And that PWA will keep working after Twitter is gone. Now, because the networks are down, we're going to need a new way of transmitting data. So why not do it visually? Our PWA is going to use the Get User Media API to capture video. We're going to need WebAssembly to analyze that video, and because JavaScript is too slow for this, and the whole analyzation happens in a web worker. So what are we going to analyze? What is the perfect way to visualize data in a machine-readable way? QR codes, of course. Obviously. Now, have you ever wondered how a QR code is encoded? Why does it look like this? So these are the finder patterns. This is used to recognize that it's actually a QR code. And it will determine the basic geometry. This is an alignment box, an alignment pattern. And if you have a larger QR code, there are actually multiple of them. And you can use this to detect whether the QR code is rotated, whether or not it's flipped. And this is the timing pattern. This can be used to determine the version of the QR code. And by version, I actually mean the size. Because somehow the QR code spec always says version when they mean size. Now, there are 13 modules in this timing pattern. In the terminology of the QR code, each bit, each square, black or white, is a module. And this is version 3. And version 3 is 29 modules by 29 modules. And right next to the finder patterns is the format information, and it's actually duplicated. It's once in the top left, and once in the bottom and the right. And the format consists of all the information about error correction and the mask pattern. So, but first we need to uncook the raw data, and we use a special 15-bit format mask for that. That is to make sure there are no long black or white ranges in the image. Now, look at the resulting data. We are using low error correction. That means we can expect to recover about 7% of the data when the QR code is partially covered. And this is actually how you can place a logo on top of a QR code. The logo actually covers the data. The data doesn't go around the logo, but the logo covers the data, and then the error correction is used to recover what was beneath the logo. And then there's the mask pattern. There are 8 types of patterns, all which are baked into the algorithm to encode and decode QR codes. And the patterns are defined by simple mathematical formula. And when encoding, it is applied to the raw data using XOR. So this is what we're using. It's pattern 2. It's basically vertical lines every 3 modules. And if we are decoding, we need to do the reverse of XOR. And that basically means this is our raw data. The data starts in the bottom right. We have a block for encoding mode, and then a block for the length of the data. And the encoding mode is just 4 modules. In our case, the data is encoding using format 4, which is Latin 1 string. And there are also encodings for alphanumeric strings, and Japanese kanji. And this is the block that contains the length. It's 8 modules. But it depends on the mode and version of the QR code. In our case, we have 33 characters of data that we need to decode. And since we're using Latin 1, each character is 1 byte. And the data is snaked across the QR code, followed by an end message terminator. And if we decode that, we get HTTP ://HTML5 test /twitpocalypse. And the remaining data that are blocks of Reed-Solomon error corrections. Now, you probably know more about QR codes than you ever wanted to know. But we now know that we have a code that can represent a fairly limited number of bytes. It is error resilient and can be machine read. So how can we use this to transmit a GIF? So let's go over this. We take our cat GIF. It's 128 pixels by 128 pixels, and we split into 64 segments. And because we're not going to transmit this image in one go, there's too much data, we're going to split it up and load it progressively. So each of these segments is a PNG image of 16 by 16 pixels. And we encode it using base64, that's just a text string. But the header of each PNG is identical in every segment, so we can skip that and encode only the data that actually matters. And then we encode that data as a QR code. You'll notice there are 56 QR codes. That is because some segments are identical, we only have to transmit them once. And some segments need two QR codes. So in the end, we are left with 56. And we show these codes after each other, 4 per second. And it just takes shy of 13 seconds and will transfer almost 5,000 bytes. So in practice, we created a visual 300-baud modem. And that is faster than the modem in my first computer. I'm old. So on the other hand, we'll use the camera to scan. We'll use web workers. We'll use WebAssembly to analyze the QR code. And we're using a library called ZBar, which is a QR code decoding library written in C. And it's old. It's from 2007. I'll put it in other terms. It's on SourceForge. But do you know that you can actually use a barcode detector API? It's available in Chromium-based browsers like Chrome and Edge. So let's see how this works in practice. Right. Okay. So we want to share an image. And there we have the QR codes. Now I have my phone here. I'm going to click receive. And I'm going to point it at the screen. And there it is. And now I can save the image and share it to other people. And so basically, we don't need Twitter anymore. Now, I know you're saying, this only works on close range. But you can also do this long distance. It's actually really simple. I have this printer here. Let's turn it on. And if I click here, I'm going to connect to the printer. And there are now 51 QR codes printing. And I can put this in an envelope and send it to anywhere in the world. 。 So this is it. Thank you, and I'll hand it over to Dylan.
Yes.